Hey, can you hear me? Yeah, there are people waving, so I guess it's time to start. You guys have no idea how cool it is to see this many people attending a session like this. When I sent in this abstract, I didn't actually think that I would get this session. And when I did get it, and I was approved to come here, I thought I'm going to get this little tiny room with about 20 guys in it, because that's normally what I see with sessions like this. But it seems like .NET is really growing up, and the developers are actually moving to a point where they care about patterns, they care about how we build things. It's not just about solving a problem, it's now about solving a problem in a good way, and doing it in a way that will work not just today, but actually tomorrow as well. And with this stuff that was announced this morning with vNext of ASP.NET and .NET, we're going to see a lot of the stuff that I'm going to be talking about here, like the dependency injection is going to be a part of the framework at its core. So you're going to see much more of the stuff that I'll be covering here coming into the framework and being a really important part, so you really need to understand that. And also, I kind of know that you guys are here because you care about the subject. And how do I know that? Because my next slide is, who am I? I'm not a big name. I'm not Scott Hanselman, who apparently, I think, managed to fill this room when he was here. So you must be here because you actually care about what I'm talking about. So let's have a little thing. We're going to be talking about applying solid principles in .NET and C#. The solid principles are just principles. They're not connected to any technology whatsoever. There's no solid framework that you can download or anything like that. It's actually just principles. They're just 5 simple principles. And the goal of today is having a look at each one of those principles and explain what they are, why they're there, and what they'll help you with. So who am I? My name is... I love that picture. I'm never allowed to send it in anywhere else where it's official, so I actually thought when I put it in my slide deck, that's never going to be allowed. They didn't tell me anything about it, so I'm just leaving it there. My name is Chris Klug. I work as a software developer at a small company in Sweden called Active Solution. We do custom software development for clients where like a predefined system, pre-built thing, just turnkey stuff doesn't quite work, so we build custom things all the time. Yes, I am from Sweden, so if you don't understand what I'm saying, tough. It's just the way it is. And yeah, if you see me roaming the halls and you want to ask anything, just come up to me and ask me whatever you want. I'm available throughout the week. I love to talk to you about anything that's .NET related or kiteboarding or skydiving, whichever. But today, the goal of the talk is to talk about the solid principles. But before I get started, there's something I want to check out. So how many of you have heard about the solid principles? Hands up. OK, keep them up, keep them up. I know we're devs, but you've still got enough muscle to keep your arms up. Sorry. OK, so it's really hard to see, but that's probably 90%, 95% of the people. How many of you can name all the 5 principles? Lost about half of you. OK. There are a few brave ones. And which one of you who've got your hands up want to keep it up and say that I can explain Liskov's substitution principle? All 5 rules? Oh, I lost a few hands there. So there are 1 or 2 hands still up here. You guys might want to leave. Just a little hint. But yeah, I'm going to go through it. You'll understand it. And Liskov's, actually, I brought this up. I asked a friend of mine, Miguel Castro, who's actually going to be here later this week to talk about dependency injection. I called him up and I said, can you talk to me a little bit about Liskov's substitution principle? And he said, yes, it's this and this. And I'm like, no, it's not. Yes, it is. No, it's not. We went back and forth, and he said, the way that I explained it, we should just remove it from the solid principles and call it the SOID principles. I'll explain it, and you'll understand it. It's not that complicated. So the presentation today is going to go back and forth between a bunch of slides and a bit of code. I'm sorry, but I'm not going to be coding anything at all. I have a pre-built application, pre-built code, so you won't see me standing here trying to figure out the keyboard. But I want to show you the application that I've got. So I've got this beautiful application. up here in the RAG folder. RAG means rough as guts. It means I have just put stuff in there and got it going. My application looks like this. It's a classical console application. It doesn't do a whole lot more than it reads in a source file, opens the file, reads the content. It's an XML file. It takes the contents in the XML file, converts it to JSON, and serializes that to disk. Just a basic content converter. This works, I think. It did last time I tried. But it's kind of the crappy code that you churn out in the first iteration, just get it to work, get it running. I want to take this code and go through it and put the solid principles in there and start splitting it out and explain one principle at a time, moving from this implementation to a fully fledged sort of solid-based application. Hope that makes sense. If it doesn't, well, that's what I'm going to do anyway. So let's, now that you, did everyone, well, sorry, just one question. Did even you guys in the back see the code? There are a few shaking heads. I'm just going to make this a little bit bigger so people in the back can see it. Is that enough? Can someone yell? Yes. Thanks. We need a bit of interactivity, okay? Tried hands up, that worked. Now I'm going to voice, that worked well. Okay, so the principles. Naming them to begin with. Not all of you were comfortable with naming them. You got S, SRP, single responsibility principle. O, open-closed principle. L, Liskov's substitution principle. I, interface segregation principle. And D is the dependency inversion principle. And yes, that is dependency inversion principle, not dependency injection principle. Just, there's a difference. So we're going to start by looking at the single responsibility principle. And the definition of that is a class should have only one reason to change. That's simple enough, right? A little bit different than what you normally hear. People will go, a class should only have one responsibility. Okay, it's a slight difference. Only have one responsibility is pretty fuzzy. What is a responsibility? It kind of depends. A class should only have one reason to change. Well, there's always only one reason to change. Changing requirements, right? So I've solved that one. We can just keep building. We don't even care about single responsibility because there's only one reason at all times. Not quite. So if we take that and we change it into, there can be only one requirement that when changed will cause a class to change. That's actually much more precise and much more to the point. Basically saying that when we build a class, we look at all the requirements for our system or the requirements that affect that class, and we build it in such a way that only one of those requirements will ever cause the class to have to change. For me, that takes it pretty far from it should only have one responsibility. My application has one responsibility, to run. It's not really precise enough. If you think this, it actually makes you think in a different way and makes you implement it in a different way in most cases. So I have this thing here. Somebody told me when I started programming, I don't have an official degree or anything about computer programming, I'm self-taught, but somebody told me along the way that nouns are classes, verbs are their functions, and adjectives, whatever it's called in English, are their properties. Has anyone else heard this? I've used this a couple of times, and the last 10 times I've said it, people have looked at me like I'm crazy. It's like, I've never heard that. Okay. I've heard this. This is pretty good for building object-oriented programming stuff, but we have to start thinking a slightly different way when we start doing solid stuff and we start looking at single responsibility. We might want to have a look at nouns being classes. Yes, that's obvious. Verbs are their functions. Might be true, but we might also want to start looking at taking functions or our verbs, things we need to do, and turn them into classes as well. Because as soon as we start taking the little pieces of functionality that we've got and pull them out into different classes, we get a class that's actually responsible for one thing and can only change if one requirement changes. And it makes it a whole lot easier to change the way our application works because we can switch out functionality without having to modify classes, but changing the classes that do the functionality. So the code that I've got, we'll look at breaking that up. First of all, I started out by refactoring my code a little bit so it's easier to read. And I came up with this. I got my main class. It has a source file name and a target file name. It has a method now they call it basically get input. It takes a source file name, gives me a stream, or actually it gives me a string. It takes the string, parses it using getDocument to a document class. And if you wonder, the document class is really complicated. I didn't feel like going anything further. It's the principle that counts. After I got the document, I have another method that serializes it to disk. Actually serializes it to a string, and then I have another one that persists it to disk. So it's easily broken down into things like that. So this is what you'd come out of doing a simple refactoring without thinking about breaking out classes and things like that. Taking it at one step further and actually introducing a bit of single responsibility, because that thing is breaking so many rules at the moment because it's doing everything on its own. So I refactored it so that my class looks like this. This class is now responsible for one thing only, figuring out what source file and what target file to use, and then it shoves everything off to another class to do the rest of the stuff. OK, that other class is now breaking a whole lot of things, but OK, that's at least one step out. And I've got my convert format, which in turn has broken down the things that needs to be done. Basically, the method I had before are now broken into little external classes that do one thing. I've got a document storage class. It's got one single responsibility: read and write, or communicate with storage. Basically, read and write my information. I got an input parser, a class that basically parses my input, my XML, and gives me a document back. I got a document serializer, the guy that's responsible for serializing my document down to a string again. So I've now just simply taken all of my methods that I identified in the first step, in my refactoring step, broken it into different classes. Very, very simple. Each little class becomes really simple. Input parser. It's about that much code. Very, very easy to read. Really simple, nothing complicated at all. And all of my classes basically turn out to be the same thing. They're tiny little things, really easy to read, really simple to implement, really hard to get wrong. And that's one of the things. We want to make our classes so simple and small that it's hard to actually make a mistake. It's hard to put stuff in there that causes problems. And I've also put in some exceptions that can be thrown and things like that. It handles everything nicely. And my document serializer here is just as simple. Somebody might now argue, why did I implement a document serializer when all I call is JSON convert.serialize object? Why not go straight for JSON.NET and use JSON convert straight away? Well, it just felt good at the moment to do it like this. I will come back and I'll actually switch that out later on. So basically, taking that step already now and not locking myself into using JSON.NET, I'm open to the idea of being able to do another serializer in the future. So break it all down, give them each one single responsibility, one single thing that they have to do. That's all a class should be doing. What about repositories, though? Or other edge cases? We're sort of on the verge in some cases. I don't know why repos came up as the first thing I thought of, but repositories are one of those that I argue a bit back and forth with people, especially people at work. A repository actually does two things, right? It both reads and writes things to whatever storage medium you got in the back end. That's fine from a single responsibility point of view if you never have the situation where you want to split that out. What if I want to modify the way it reads things but not the way it writes things? So depending on the systems we're working with, SRP will actually come out with different solutions for the same things in different scenarios. Make sense? I'm currently, for example, working on a project where we're using CQRS and we're using read and write models. In that case, a repository is not, which does both read and writes, is not a really good solution, because I actually want to target two different systems for the reads and the writes. That means that I now all of a sudden have two different requirements that can change. And all of a sudden, I should be breaking it up into smaller pieces. So I'm not saying that single responsibility is simple. I used this really ridiculous tiny example and broke that into this, and it became quite okay. But every single time you're building a piece of code, you have to go through this. You have to think about what can happen, what are my requirements, and there's not a single solution to everything. It's not possible to say that repositories, for example, would always be the same and always be single responsibility. They're all up to whatever context you're in at the moment. Benefits? I guess there should be some, right? Kind of sucks if there's not. The benefits would be the fact that it's now an application that I can compose in different ways. I can switch out bits and pieces, but I don't need to go in and modify my codes in a lot of places. I can switch out components and plug in other components. That's one benefit. Another benefit is the fact that each of my components are now really, really small. When you go from really big godlike classes down to really tiny classes, they become like really simple to read, really simple to understand, and very precise as to what they're doing. And the smaller you make them, the easier it is to build something that's not going to fail, that's not going to break. So the next principle, which builds, this is the cool thing with Solid, they all build on the previous principle, basically. So if you follow single responsibility principle, then you can start adding open-close principle. It's more or less impossible to add OCP on top of an application that doesn't have single responsibility, because you're going to shoot yourself in the foot. It's going to be really hard. So the open-close principle says that software entities should be open for extension, but closed for modification. That's simple, right? So I should write code that can be made better without changing it? Seems like a really simple way of doing things, right? It's actually not that hard. The deal is, once a class is done, it is done. You do not modify it. Once you've put a class and said, this is what it's going to do, here is the implementation, you do not change it. A changing requirement, here we come back to the requirement, which comes back to the single responsibility stuff. Once a requirement changes, you do not modify your class. You do not go in and make changes in your existing class. You create a new class, inheriting from the old class, and you make your changes in the new class instead, and then you start testing that class, and you start working and plugging that class into your system once you've tested that and that thing is up and running and working. Make sense? Know the best part of it? I'm not a big TDD person. I say this at every place I come. But I don't like, I got an aversion to unit tests, because if you build a big set of unit tests testing your components, and then all of a sudden you need to make a change to it, you have all of this test that needs to be changed as well. The only reason that comes up is if you're breaking open-close principle. Because once a class is done, and you have your unit test, and you're testing that class, it's doing what it should, you're done. You never change those tests. Because anything that changes that would cause you to change those tests means that you should be creating a new class, and you should be adding new tests to that class instead. To me, that's a good upside. So Bertrand Meyer versus polymorphic. Bertrand Meyer was a French software dude a while back who's called basically the father of open-close principle. So he says that once a class is done, it should not be changed unless there's a bug in it. You're allowed to fix bugs in your classes, but once you have a feature change or a requirements change, it's a new class. His idea is that you build a class, you put that into your system. Whenever you need a new one, you inherit from that class, you make your changes to it, and you plug that into the system. Polymorphic came up a little bit later on and builds on the idea that we not necessarily have to inherit from a specific implementation, that we could actually be inheriting from an abstract base class, or we could be implementing a specific interface instead. So those are two variations of open-close principle, but they have the same idea. Once you've built a class, whether it's a class or it's a subclass inheriting from an abstract base class or a class implementing an interface, once you're done, you stop working on it. That's a final piece of code. You check that into the system, and you don't modify it again unless there is a bug. So if we look at opening up our application for extensions and putting in some extensibility and closing it down for modification, just need to manage to log into my computer. So I've got open-close principle. I got a new project here. It's, once again, same project. All I need to do is basically modify it into the way that it follows open-close principle. So I had that input parser. Looks like that. Input parser parses XML and returns a document. That's all it does. Very simple class. However, someone comes along and says, what if we have input files of type JSON instead? I very recently, which means last 2 hours, figured out that that's probably not going to happen, because what this thing does is it converts things from XML to JSON. So JSON to JSON is not actually very helpful. But if somebody asked me to do this, I would go in and follow the open-close principle and create a new JSON input parser. And I would inherit from input parser. That's according to Bertrand Meyer, the Meyer open-close principle. Basically, I just take it, I inherit the implementation that I've got, and then I override whatever I need to make the changes that I need. I've also introduced a couple of the polymorphic kind. So if I look at document storage, what if I decided that I wanted to have more than just a file storage? What if I wanted to read and write to other places than just to disk? Maybe I want to do it to Blob and put it into Azure or some other place, or I want to put it on the web or whatever. So I introduced this abstract base class called document storage. It's completely abstract. There's no implementation whatsoever. It's just an abstract class. And then I created implementations for it. So I've got a blob document storage, a file document storage, and an HTTP input retriever. I'm going to come back to the HTTP input retriever, because it's going to be violating the next principle, because it doesn't actually implement the persist document. Because if I'm just reading things off some public web server somewhere, there's actually no way for me to save things to that web server. That requires a bit more. So it just throws not implemented in this case, and I'm going to get back to that. And the format converter that I used, which I got in here, now has a little method down here that checks the get document storage for file name. And it basically looks if it's a blob storage URL, then I get the blob storage one. If it starts with HTTP, I get the HTTP one. If it's not, then I get the file one. So basically, I've made the possibility of switching out my document storage based on the URL or the path to the file, but it's still in here in a way that it has to figure it out on its own. And I also implemented a iDocument serializer. So instead of doing an abstract base class in this case, I decided that an interface would be much more useful. So I created a simple iDocument serializer, serialize method, and then I created a JSON document serializer and a camel case JSON serializer version of it. So basically doing this, with having the single responsibility stuff implemented and done, I had defined all of the classes that I needed. Then I took it one step further with this and defined what do I need to be able to change and how do I want to do it. Whether or not you go for the Meyer version where you have an actual implementation that you override, or if you use an abstract base class or if you use an interface, it doesn't really matter. It's up to you, and it depends on the situation. You just have to figure out what you want to use in what situations. So now that I've got my open-close principle stuff going, I've actually got the ability to switch out bits and pieces in here in my constructor by basically saying, oh, in this case, I want to use the camel case JSON serializer. Now I want to use the JSON document serializer. I can figure out what document storage to use, but all of this is still inside my format converter. So now I've actually introduced a little bit of single responsibility breakage in that class, because it's all of a sudden have this logic regarding what to do and what to use and everything. But I'll fix that later on. But my application is now all of a sudden pluggable. I can put things in there. I've managed to extend my application and add new functionality without actually modifying any of the existing functionality. So there are a couple of potential questions here. So especially if you go with Meyer and you decide that you want to have an actual class implementation that you inherit from and override, there's a massive question here, and I don't know how to answer it because I couldn't answer it on my own, and that's how much do we make virtual? Because in C#, you can't actually override anything unless that member is set as virtual. So unless you make your class and have some methods that are virtual, you have no way of actually implementing open-close principle. You can't actually inherit it and change it. And on top of that, you're not allowed to change your class. You're not supposed to change your class once you're done with it, so you shouldn't be going back to it and just changing it from not being virtual to being virtual, because that's actually modifying your class. So somehow you have to figure out how much of my application of that class do I want to make it possible to switch out. But it depends on situation to situation. You have to look at it and make a guess when you build it, and then potentially go back and change it in the way that adding virtual or removing virtual and things like that. Also, where do you define how much you're allowed to change your class? It's not always so simple to see the difference between a bug and a feature change or a changing requirement. So that's another one of those where it's a little bit complicated to figure out, but once again, it's all dependent on the context you're working in, dependent on your system. And also, the most complicated one, which I haven't been able to get any real answers for, is how does this work with interfaces and base classes, or abstract base classes? It's a little bit harder because you're actually not inheriting from anything, so you're not changing functionality, so you have to really know what your abstract base class or your interface is supposed to be doing. So you have to document what it's supposed to be doing, because every time you build a new class implementing that interface or inheriting from that abstract base class, it has to be very clear what you're supposed to be doing in that class, the intent of that interface or that abstract base class. Benefits. It means that you don't have to rework all your unit tests. Is that a good benefit? Now, actually, the biggest benefit of this is that you don't change code. Once you know it's working, you don't change it. As long as you don't change code in existing stuff, you won't break it, right? If it works, it works. If you change it, it might not work. This thing forbids you to go in and change things. And once again, if you don't change it, it won't break as long as it's worked from the beginning. It also means that we can test things, get it properly tested, get it done. This is the way we want it to work. Then we put it into production. We just switch things out. And then we come to the Liskov substitution principle. How many said that they could explain that? I saw one hand down here. Want to come up and explain it? No. Kind of thought so. Because this is the explanation. Let Qx be a property provable about objects of type T. Then Qy should be provable for objects Y of type S, where S is a subtype of T. Any questions? Can I go on to the next? Can I go to interface segregation? Actually, this is brilliant. It is. hat off. But it took me 2 weeks before it dropped and I understood it. Now I do, and it's actually quite brilliant. I will break it down and make it a little bit easier, because I'm pretty sure that is what the people who heard that the first time said. So this comes out of a keynote called Data Abstraction and Hierarchy, I think from Barbara Liskov quite a while back. And if I heard that, I would have been sitting there going, hey? So the simple conversion of that weird stuff is a subclass should behave in such a way that it will not cause problems when used instead of a superclass. A little bit more sense, right? It kind of means the way, if you inherit a class, once again, we build upon the open-close principle. I inherit a class because I need some new features, new functionality. The changes that I make to my base class in that new class is not allowed to make any changes to the implementation in such a way that it could break any code that's potentially using that implementation at the moment. That's simple, right? Just take it, modify it, but don't make any modification that will cause any changes. Okay? Luckily, there are rules, kind of in quotes. Contravariance of method arguments in a subclass is allowed, and covariance of return types in the subclass. Is there anyone out there that needs explanation of what this means? Yes, thank you. There are a few brave souls going, yeah, mate. The rest of you, you are so lying. Sorry, that's just the way it is. So contravariance of method arguments in a subclass means that if I have a class, I create a new class that inherits from that class, I am allowed to change the input arguments to my method in such a way that they accept a base class of the arguments that my base class accepted. It basically means that I'm allowed to change the input parameters in such a way that any parameters that has ever been passed into the parent type can be passed into the new type. Sweet. Covariance of return types in the subclass means that the return of my class, the return value of my method, is allowed to be any type that is the same as the parent or a descendant class. Once again, I'm allowed to return anything as long as it's at some point inherits from whatever the base class returned. Makes a little bit more sense than that, I hope. The cool thing about this is that it is virtually freaking impossible to do in C#. So we can ignore this. Trust me, I tried. I had a long, hard try, and I had this idea. If I start using dynamics, can I somehow freak out the .NET runtime to a point where I can change my input arguments and my output arguments in such a way that I can get to this? No. Does not work. It makes sense if you're doing pointers and things like that, but if you're actually inheriting things in C# in .NET, it is freaking impossible. And if you have any way of doing it that I don't know of, please come up and tell me after the presentation, because I really want to figure it out. The next one is no new exception types are allowed to be thrown unless that's a misspell, it's supposed to say they, not the Y, are subclasses of previously used ones. Pretty much, in your new class, you're not allowed to introduce new exceptions. Why? Well, if you introduce new exceptions, whatever code has been using the other class, your base class, might be prepared to handle whatever exceptions that class is throwing. If you start introducing new ones, things might blow up. Your application might break. Here's another one. Preconditions cannot be strengthened in the subtype, and postconditions cannot be weakened in the subtype. Anyone need explanation of that? It kind of means preconditions cannot be strengthened in the subtype. This is a really poor way of describing it. You cannot be expecting things that wasn't expected in the base class. I cannot make changes so that, hey, you're only allowed to call this method if this property is set to this value, if the base class hasn't had that limitation before. So you're not allowed to introduce things that might cause, once again, any class using the base class cannot break because you've introduced new features or new limitations. And post conditions cannot be weakened means that I'm not allowed to change the class in such a way that you cannot do things you could do before. So I can't start throwing not implemented exception or say you're not allowed to do this or that or whatever, because once again, if I introduce a change like that, code that was using the base class cannot use the new type and might actually fail. And then there's the final little thing called the history constraint. The history constraint means that you cannot make an immutable class mutable. So if you have a class that cannot be changed, you have a property of a class that cannot be changed in the base class, you're not allowed to change that class in such a way that you can change the value in your new class. Because any type or any class using the base class might be expecting that that value can never change. If you all of a sudden start introducing the possibility of changing it, once again, you might be breaking things. So basically, before I go into code, the general guidelines when it comes to listgovs is actually what Miguel said. Miguel did not say I should throw out listgovs completely. He just did not want to admit that there were a bunch of specific rules. The general idea is you are not allowed to change a class in a way that you can break any existing applications. And then you have these rules to define what could break an existing application. So I created a little bit of code, and here is where my demo kind of falls apart. I had to do this in a different way. I could not figure out how to put listgovs into my application. So I've actually created a whole separate little project where you can see listgovs different things, because I couldn't find it in my application. The only place I found it was that thing that I mentioned before. It is that the document storage. That is not acceptable. I cannot start throwing things that the potential clients that were using it before didn't expect. So instead of doing it in that project, I came to the conclusion I will show you the different principles, but I'll do it in a different project. So I've created a little test project to just show that it works, and all of these tests, they work. So covariance and contravariance thingamajigs of this method signatures I just ignored. There was a little dynamic thing in there before, but it didn't work. But I introduced this thing. I've got a car, right? Very simple class. It looks like that. It takes a color, sets the color. It's got start engine, stop engine, and it has a little has fuel thingamajig in there. And the only thing these do is basically, if it doesn't have fuel, it throws an out of fuel exception. Otherwise, it turns on the engine. And if you stop it, it stops the engine, right? That's about as basic as we can get. So I wrote these tests to verify that that class works. Make sure that it can start. Sounds like a reasonable test, right? So I create a new car. I start the engine. I'm looking for out of fuel exception, which should never happen, but yes. And then I make sure that the engine is running, right? That works. Then somebody comes along and says, I'm going to inherit that. I'm going to create a broken car. I have a broken car, and whenever you call start engine, I'm going to throw not implemented exception, because it's broken. It won't start. That is an obvious contradiction to listgovs. Basically, I'm introducing a new exception, and if I were to run this test now, this test will fail, because I'm not expecting not implemented exception. I am expecting potentially out of fuel exception. I'm not allowed to go in and make changes like that. So I've basically broken the post conditions cannot be weakened thingamajig, because I've changed what you're allowed to do. I introduced a new one, a crime boss car. The crime boss car has another one of those. If I run this, you'll see why that doesn't work. It throws a met your maker exception with the message, boom, you're dead. Because the crime boss car actually has a booby trap. And if the booby trap is set, it throws an exception, right? Once again, I'm throwing exceptions that I'm not allowed to do. Once again, somebody might be using car, I pass in a crime boss car, and all of a sudden my application breaks. I have another one here, another test. Make sure engine is running after start. That seems pretty obvious, right? Turn the key, start the car, engine should be running. Something that an application could be considering to work with and try. So I have a car, I start the engine, it's running. Then somebody comes and creates a Prius. I don't know why you're laughing at the specific Prius, but the Prius. Yeah, so the Prius is different. Anyone own a Prius? Okay, I'm not going to say anything about the Prius. It's a fantastic car. And one of its features is that it doesn't actually start the engine when you turn the key. It turns the engine on and off a little bit back and forth, depending on how fast you're going. It's got an electric motor and all of that. So start engine is overridden and does exactly that. Doesn't do anything. Flips a switch and says whenever the guy pushes the gas pedal, then potentially start the engine if he's not pushing it too hard. So that breaks it again. Minor change. I've just changed what you're allowed to do, but any code that could be using it could be depending on the engine being started after you turn the key. You're breaking it. Somebody introduces a stolen car. Stolen car changes the preconditions. You know stolen cars, I've seen movies. You have to strip the ignition wires first and then combine them to start the car, not just turning a key. So I have this thing. Basically, you have to call strip ignition wires before you can start it. If you don't do that, the car won't actually start. That doesn't seem like a big problem when you're coding it. I'm kind of hard-pressed to find a situation where you would build a class like this. I don't know. But if you were, once again, this test will fail. It will not work. And finally, make sure the car is painted correctly. Have my car, make it red, make sure that the car is red. Could be obvious. That little thing is not possible to change. It's immutable, right? The implementation of it basically just sets a color, which has a protected set, so it's not possible to change it externally. But then I create a pimped car. That should potentially have been pimped out car, but yeah. And I make it red. Then I change the temperature of it, and that changes the color of the car, right? Obviously, because my pimped car uses this cool new, there's a link here that goes to a place. There's actually new paint that you can put on your car that when it gets cold enough, it changes color. So just imagine that I have that car, and if I change the temperature, and the temperature goes below 20, if it goes below 20, I make it black. Doesn't seem like a big problem, but it is, because I might not be expecting that. I'm expecting that color to be constant. That should never be changed, it should be immutable. So I'm violating the history constraint in that case. So as I said, I couldn't get all of it into my existing project, but as you can see, all of these minor little changes, every single time I inherit that class, I make a little change to it, and it breaks. The general idea, this is not going to hold up in all situations, absolutely not, but you should most likely be possible to take your new class and throw it in and run it through all of your existing unit tests, and they shouldn't fail in the way that they break down. You would then have to check some of them might fail and give you red because you've made some requirement changes and you changed the class and they should be going red, but at least they shouldn't break down. They shouldn't puke all over your test runner and go, I can't run this anymore. That is the basic idea behind Liskovs. So what about abstract base classes and interfaces? That becomes a whole lot more complicated. It's one thing if you're inheriting from a class that actually has an implementation, because you know that that class has basically told the system that these are the exceptions I'm throwing, this is the functionality you can expect, and this is the features that I offer during these circumstances. And then you know that whenever you inherit that, you have to adhere to those rules. But if you're looking at abstract base classes that don't actually have an implementation, or you're looking at interfaces that don't have an implementation, they don't necessarily define what exceptions are allowed to be thrown, what preconditions you have, what postconditions, and all of that. So it becomes a little bit muddy when it comes to this. You'll have to figure out how to solve it. I'm not going to tell you because I don't really know. I'm honest, at least. Benefits? Well, I think it's pretty obvious, right? The benefits are, I've gone through a single responsibility, I've done open-close principle, I've got all of these tiny little classes, I've got a gazillion tiny classes that I'm not allowed to modify, so I keep adding new versions of them over and over and over and over again. I need to make sure that when I start adding all of these new classes and all of these new implementations, that existing systems don't break. ListGovs, if you follow the rules of ListGov, you will create classes that will actually be able to plug in and replace the existing implementations without you breaking existing applications. Interface segregation principle. So interface segregation principle is clients should not be forced to depend upon interfaces that they don't use. Yep, it's about that simple. I don't want to have classes having to get this massive interface with a whole lot of functionality when I only need a little bit of it. So we want to break down our interfaces in so small pieces that a class or somebody using that interface only gets exactly what they need. Yeah, that's a valid point, right? Who cares? If you get too much, just ignore it. The problem is that when I get too much ice cream, I tend to eat it. If you give a class too much functionality, he tends to use it, and he might not want it. You might not want him to. So break down your interfaces into smaller pieces because it will make it easier to implement that piece of functionality. Once again, you're coming back to a bit of the single responsibility stuff. If you make a really small interface, it's really easy to implement. It makes it really easy to switch out, and a person or a class can be dependent on just a little bit of functionality. So if you start looking at some interfaces, you got code? Yes. I couldn't find that many interfaces to break down. So one of the problems with building a simple project like this and showing it on stage is that you want to have a project that is small enough to demo, but big enough to not be like a Hello World application. And in this case, for the interface segregation, there wasn't a whole lot I could do. But I did take my document storage, and I kept the abstract base class because I want to have the implementation like that. I can keep that if I want. But I did introduce two interfaces, INputRetriever and IDocumentPersister. Basically, it means that I've now broken down the idea of getting information and storing information into two separate interfaces. And it means that, you know that document storage that I had that was breaking the implementation, the HTTP input retriever? That can now implement only INputRetriever. It doesn't have to throw a new exception or throw a not implemented exception because it's trying to implement things it doesn't have. By having these really small interfaces, it's really simple to implement them, and I can require them. And anyone using input retriever knows that that's what I'm getting. That's all I need. I want to be able to pull out data. And anyone using the IDocumentPersister needs to persist things. If I don't need both, then I don't request both. I don't ask for both. I just take the one that I need. So in general, That's a fairly simple point in the interface segregation principle. Just break down your interfaces. Don't make them these big monolithic interfaces that, oh, I want to implement this little piece of functionality here because I want to do something, and then I have to do all of that. You can be combining your interfaces into like super interfaces. So you can take a lot of very small interfaces and put them into a bigger one if you want to. That might help, because in some cases you end up with like classes needing a whole heap of different interfaces, and if you do dependency injection and constructor injection, your constructor needs like 4, 5, 6, 8, 10 different interfaces to do its work. In some cases it can be good to create a combination, but it does have issues doing that. It kind of breaks this thing again. And also, if you have a class that requires 10, 15, 20 different interfaces, any potential that it's actually breaking the single responsibility thing? Yes. You were supposed to go, yay, yes, he's going to, okay. Sorry, you're not all asleep. Benefits of this, you get really small, tiny pieces, easy to implement, easy to switch out. You can have tiny little interfaces, and you can have your class implement 10 of them if you want to. That's not a big problem. But the guy needing the functionality can ask for a little bitty piece of it. He doesn't need to have the whole thing. Just how many of you have worked with ASP.NET's membership providers? I got a little laugh down here from the Microsoft guy. How many of you love the membership provider? There's one brave soul. Okay. Yeah, exactly. Huge interface. I like the membership provider. I like the idea behind it. But the fact that if I want to switch out how I retrieve my users, it's not uncommon that I want to build a website where I want to be able to retrieve users from some custom store somewhere. I can't actually do that without implementing a gazillion other things like update user and update password and password reset and all of these little things that I don't care about. So how do you solve that? Well, you inherit from membership provider, and then you just go throw not implemented exception in 98% of the methods and implement the 2 little pieces that you need. Massive fail. I think I'm allowed to say that now. They've moved away a little bit from the membership provider, so I hope that. I'm trying to switch my MVP to ASP.NET. I might have just, yeah. Oh, no worries, thank you. Okay. So the last one, dependency inversion principle. And yes, it is dependency inversion principle, not dependency injection principle. There's a massive difference between dependency inversion and dependency injection. Okay? It's the first thing to keep in mind. So definition of this, I think I pulled it off Wikipedia. A, high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend upon details. Details should depend upon abstractions. Yeah, so everyone should depend on abstractions. We got that. Is anyone actually going to implement anything? Because yes, he's not going to be dependent on anything. He's not going to be dependent on... Yes, someone needs to implement something, as long as he doesn't depend on anything implemented. Okay. I'm not really selling this principle, am I? Basically, if my classes take dependency on some specific implementation, I lock myself in. I make it a lot harder to change things. By making sure that they don't depend on specific implementation but abstractions, I can actually just change out my implementations however I want and make all of these changes. So I've got this thing here. Just imagine this. It looks very similar to the application I've built. The app uses a persistor, and the persistor uses system.io.file to save information to disk. OK? That's cool. Not really, because it means that my application can never, ever move away from using file. Due to the fact that my app is dependent on the persistor class, I have implicitly taking a dependency on system.io.file as well. That's not good. I will never be able to reuse persistor anywhere that I want to use the other functionality that persistor has, unless I want to save things to disk. If I switch that out and make the app dependent on iPersistor, the implementation of iPersistor depends on iStorage, and iStorage basically has some form of implementation that stores it, in this case, to system.io.file or whatever. It means that my app can switch out the persistor. So if my persistor has some logic in there, I can switch that out for other logic. Once again, going back all the other principles backwards, it's really useful to be able to switch out things. And once again, if my persistor is dependent on iStorage, I can switch out the iStorage, so my app can still use the same persistor, but I want to be able to switch where it actually persists the information. It gives me so much more flexibility because I can just do that. I can switch the persistor for my X persistor, and I can switch my storage for Cloud Blob storage instead. All of a sudden, I've got all this flexibility of being able to move things around in my application, which I didn't have before. But as soon as I put anything, any dependency, without having an abstraction on top of it, I cannot change it. I cannot make modifications. Whenever you see anything that you might want to switch out or might want to change, put an abstraction on top of it. I've gotten to the point where I don't rely on anything, more or less. If I see that I'm going to be writing to disk or saving something, persisting something somewhere, that becomes an interface, because I want to be able to change it. I know that my boss is going to tell me that it's going to be disk right now and it's always going to be disk, and I know that 4 months later it's going to come and tell me that we're going to be working with Azure and it's all going to be in blob storage. And if you imagine that I had followed the other solid principles more or less, but I didn't have my abstractions, changing out my storage means that I would actually have to go all the way up and switch out my class, because I'm not allowed to change things along the way, right? So all of a sudden, I have to change out the whole system. So I pulled up a couple of different dependency inversion strategies and put those into my application. There are a whole bunch of different ways of doing it. Most people, whenever you start talking about dependency inversion, people will throw out, oh, I need an IOC container. I need to pull it in inject, or I need Unity, or I need AutoFac, or something like that. And I want to configure all of this complicated stuff, and it takes me forever before I can start working on my application. You don't need that. You don't necessarily need to do IOC containers to do dependency inversion. There are other ways of doing it. So I've done 3 different versions. I've got a manual one, where I don't take dependency on anything. Once again, taking a dependency on an IOC container, it's a dependency. So you've got a dependency on something that's going to keep your abstractions. So you want to put an abstraction on top of your thing that keeps track of your abstractions. It's the obvious way of doing it, right? Until you have a dependency on that abstraction and one abstraction, and then it becomes really complicated. So the manual way of doing it, I've changed my format converter to take 2 classes, or an interface and a base class, as parameter to my constructor instead. That's dependency inversion. This class, my format converter, is now saying, I need these things, but I am not going to be creating them for you. I'm not going to be taking dependency on a specific implementation. I'm going to let you tell me what I need to use. That's one thing. I've also introduced a couple of factories. I've created an inputRetriever.forFilename, a static method that called forFilename. And now people are going to yell at me and say, static stuff is not good. Static stuff cannot be tested. Static stuff is crap. Static stuff doesn't have to be crap. This is a static class, absolutely. But have I taken any dependency on anything specific? No. Have I made it so that it's not testable? No. Because forFilename actually returns, you can't see that, can you? But it says IInputRetriever. So the InputRetriever static factory class just gives me back an IInputRetriever. So I haven't actually taken any dependency on any specific implementation. All I've done is I have created dependency inversion using an abstract factory instead of injecting it using an IOC container or something similar. And same thing down here for document persistor. It's a static method on a static class, and it returns an iDocument persistor. Even though I'm using static stuff in here, I have no dependency on any specific implementation. So configuring and running this requires a little bit of work. First of all, I create a document serializer, in this case the camel case JSON serializer, and inject that. The input parser is a JSON input parser. I inject that. So that's dependency injection. That's constructor injection. And then I call convert format. But the input retriever and document persister are configured down here, where I basically say input retriever, register input retriever. Then I give it a func that returns a Boolean, basically telling you whether or not this is the one that you want to use, based on if the path starts with HTTP, then I want to use this one. If the path is a blob storage URL, which is this logic down here, I want to use this one. If in all other cases, use the file storage one. For a register document persister, it's the same thing. It takes a func and returns and sets in a specific version. Implementation of these are really simple. Basically, it has a dictionary of func taking a string and returning a bool. And it takes an implementation of the I input retriever. And then whenever you request it, it looks at my dictionary and tries to find the first one where it returns true when I execute it, and then I return the input retriever. So even though I'm using a static class and a static implementation, I'm not actually locking myself into anything. I can reconfigure this however much I want. So even though I'm using the input retriever static class, I don't have a dependency on an implementation. I'm still dependent on an interface. So that's one way of doing it. That's the manual way. It does mean that if you want to do constructor injection, you do need to have somewhere where you orchestrate what to put in. You need to create an instance of things and need to inject it into the constructor to get it working. The other way of doing it is by using a service locator. Service locator is another pattern that a lot of people are, how do you put this? Less than happy with. I think is the best way of putting it. The downside with service locator, I'll actually get back to that after explaining how it works. The service locator is kind of an abstract factory like I had before, but in this case, it's actually dependent on an IOC container. So I've created an IOC container. In this case, I'm using Unity to keep track of all of my implementations. So iDocument serializer is a camel case JSON serializer. My input parser should be a JSON input parser. But then I tell, there's a Microsoft patterns and practices thing called the common service locator. It's basically a standard way of doing this. You tell the service locator that the set location provider, and then you tell it, here is my locator, which in this case is a Unity service locator. So it's basically just a way of abstracting our IOC container and not using proper constructor injection in this case. The downside with this, well, there's a massive upside. It means that when I run my program, I just create a new format converter. I don't have to create all of the classes that it's dependent on and inject them myself and everything like that. Instead, this thing in here goes in and says service locator.current to get the current service locator. And then say, can I get an iDocument serializer? And then that will return whatever implementation I've told it to use. And I can say, can I get an instance of input parser? And it will use whatever instance of input parser I've told it to use. So that's quite neat, because it means that I don't have to create all of my dependencies and inject them into the constructor. I can just use them like this. The downside with this solution, I do agree there are a couple of downsides. One is I can't see what this thing is dependent on. Whenever I create an instance of this format converter, if I don't have the source code to go in here and look at what things it's pulling out of the service locator, I won't actually be able to figure out what things is it dependent on. That's a massive downside. The other thing is, if I give him access to the service locator, it's possible for that implementation to go and ask for any interface in the whole system. It can get any service it wants. So it gets access to way more than it actually needs. That's the common thing that people say about the service locator pattern. Or you're giving him access to way too much. Who's him? To me, okay, him or it or whatever, if you go, it's giving it too much. It's like, what are you talking about? You mean the class? Yeah, exactly. He gets way too much functionality. It's like, who's building the class? You? Yeah. Yeah, so all you need to do is not pull out things you shouldn't be touching. Just saying. It's about as complicated as that. I do agree with the whole you can't see what it needs. So it is a problem. But there are scenarios where this is way easier than doing dependency injection using constructors. Anybody doing MVVM and XAML-based application development? Ever consider how you do dependency inversion within a view model that's created in XAML without not doing it from code behind, which you should never do? It's actually not possible unless you create another little thing on the side that handles all of that for you. But using the service locator, you can actually get up and going without having a view model locator in place. And finally, we have well, I think most used one, using an IOC container. So the IOC container, once again, I've just got Unity configured. I configure Unity with the different implementations, and then up here in my application, my main method, I ask the container, can you please resolve my format converter? The format converter can take things into its constructor, and your IOC container will be smart enough to figure out, okay, so you want a format converter. I've got one of those here. He wants a document serializer and an input parser. And you have previously told me that anybody that wants an iDocument serializer should get one of these, and anyone that wants an input parser should get one of these. So I'm going to create an instance of those and inject them into that class and put it into the constructor and do all of that for you. All you need to do is say, please, can you resolve a format converter for me? That means that we get the nice declarative thing going, this is what I need, this is what you need to set up for me, fix it for me, but the IOC container will actually do all of the resolving for me. And if any of these classes had any other dependencies, it would then figure out what it should create dependency-wise for that one and inject those as well. So you just put it into the constructor, I need these and these and these dependencies, and the IOC container will fix it all for you. Some people might have noticed that I've got a gray get container here, because that's not actually being used. I'm using get declaratively container. The cool thing with Unity, I think this is cool, some might argue. The cool thing with this is that Unity and a lot of other IOC containers can actually do all of its configuration in XML, in your app.config. So I can actually build this whole application without telling the application in code what versions of things to use. And then I can just reconfigure the whole application by going into my app config and say, I want to switch out this little thing for that little thing. I want to switch out this for that. And it will just figure it out. And next time I start the application, the IOC container will have that new configuration. And I've actually managed to modify how my application works without even having to change any code at all. Woo -woo. That is kind of cool. I think that's kind of cool. People do argue that having config in XML is bad, but it is quite useful in a lot of cases. Benefits? Well, as I said, as soon as you invert your dependencies, it means that you can actually switch things out and make changes, which is what all the other SOLI means. They're all about being able to switch out bits and pieces without making a whole bunch of code changes to your existing code. And with dependency inversion, you make that possible in a nice way. Whether or not you choose to use an IOC container or you choose to use a service locator or do poor man's injection or whatever you choose, I don't really care, but just make sure that your classes are not dependent on specific implementations, because it will bite you at the end, I promise you. Some things to consider. Over-engineering and premature optimization. If you go and build a big system from scratch, and you start thinking about Solid from day one, you're going to have so many classes and so many interfaces and so many weird permutations of how your application could work that it's just ridiculous. And you might not need it. Keep that in mind. It's all about drawing a line and saying, this is how far I want to go. I don't need to break it down further than this because I don't need it. So you need to take Solid together with Kiss. Keep it simple, stupid. Or keep it stupid simple, but whatever you want. Don't go too far. I'm just, as that little thing said, should everyone just be looking at abstractions? Should nobody implement it? Yeah, that's where I'm saying draw a line. This is how far I want to go. We might need to refactor it in the future and add this in later, but don't do it from the beginning if you don't need to. Readability. That's a double-edged sword. Once you go through with Solid, your classes become really small, clean, simple to read, simple to understand, and everything is good. But once you start adding abstractions and interfaces and base classes and abstract base classes and stuff like that, figuring out what's actually happening inside of your application becomes really hard. Because all over the place, you're dependent on interface this and interface that and interface this and interface that, and you have no idea until runtime what is actually being called. ReSharper, I don't know if it's in Visual Studio yet. I always put in ReSharper on my machine. Control F12 will take you to a specific implementation. So if there are more than one implementation of an interface, for example, it will tell you these are the implementations you can go and have a look at. If there's only one, it will jump straight there, while F12 will just take you to the interface. Debatability. Prepare yourself to have long, heated debates at the office. I suggest taking a course, anger management to begin with, and a couple of Vicodins before you go to work. No, seriously, there will be discussions regarding this. They tend to become quite heated because it's kind of religious how far you take this. But also, anything that's debatable, where there's not a single answer, means that there are several ways to solve it. Try to find one that works for you. If it doesn't work, then refactor and redo. It's not more complicated than that. Anybody want to guess what the 50 versus 230 is? What? Lines of code, exactly. That is my application. It started out with 50 lines of code. It is now 230 lines of code, not counting the added functionality. Or somewhere in that neighborhood. I did a very quick calc on it. But basically, it went from 50 to 230 without adding any form of new functionality. This is just the same implementations that I had to begin with. Each little piece of code is easy to understand and easy to manage, but there's still 230 lines versus 50 lines. Once again, draw a line. Once in a while, you have to step over that line, but try and sort of go, this is as far as I want to go. There's an awesome blog post somewhere online that I saw once going hello world in the console app. Basically, console.writeline hello world. And then he starts adding all the abstractions and everything on top of it and adding Solid. And it turns out being something in the neighborhood of like 20 classes, 16 interfaces, and it looks like this massive thing. And at the end, it writes hello world. So a bit of related content. I thought they would put in I'll be there, and I thought they would put that in. First of all, there's a deep dive into dependency injection. As I mentioned at the beginning, the stuff that you saw with vNext of ASP.NET and that's .NET stuff, it will have a lot of dependency at its core. So I do suggest that you go and have a look at the dependency injection stuff with Miguel. So he's going to do a full session on only that part. I was about to say that principle, but it's not actually going to be talking about dependency inversion, but dependency injection. Keeping that very separate. So that can be a good one. I'm going to be at the Microsoft Solution Experience thingamajig in the halls A and B or whatever it is. Down at the expo, there's a Microsoft area. I'll be there on and off. Don't actually know when, but I will be there. If you see me somewhere around, because I will be roaming the halls, Just grab me if you have anything to ask or any questions. If you find me, if I'm not at the solution thingamajig, I think my contact information is there, so they can tweet me and tell me to come, and you can ask any questions you want. I'll be here after the presentation if you have any questions as well. You should visit the Developer Platform Tools booth. That's where kind of where I'll be. Go to these places to find more information. Kind of not in this case, because we're kind of talking about a little bit non-technical stuff. So there are other places where you'll find this. If you just Google solid principles, you get a bunch of good articles about it. Complete an evaluation to win. It's a good thing. It says 0, on the clock here, so I need to sort of swipe through the slides here. And evaluate this session. If you thought it was great, do an evaluation. If you thought it sucked, don't. I'd love to come back next year. Other than that, thank you for listening. I hope you got something out of it.